Good afternoon. I'm Anitha, Assistant Professor in the Department of Artificial Intelligence and Data Science. Now I'm going to take about classifications of back propagation. Classification by propagation is an algorithm that back propagates the error from the output nodes to the input nodes. Therefore, it is simply referred to as the backward propagation of errors. It uses in the vast applications of neural networks in the data mining like character recognition, signature verification, etc. Next, coming to neural networks. Neural networks are the information processing paradigm inspired by the human nervous system. Just like in the human nervous system, we have biological neurons. In the same way, in neural networks, we have artificial neurons. Artificial neurons are mathematical functions derived from biological neurons. The human brain is estimated to have about 10 billion neurons, each connected to an average of 10,000 other neurons. Each neuron receives a signal through a synapses, which controls the effects of the sign concerning on the neurons. These are the inputs, that is x1, x2, x3 are the inputs, and these are the weighted nodes, and this is bias, summing junctions and activated functions. Then it comes to output. Next is back propagation is a widely algorithm for used algorithm for training feed forward neural networks. It computes the gradient of the loss function with respect to the network weights. It is very effective rather than merely directly compute the gradient concerning each weight. This efficiency makes it possible to use gradient methods to train multi-layer networks and upgrade weights to minimize loss. Variants such as gradient descents or stochastic gradient descents are often used. The back propagations algorithm work by computing the gradient of loss function with respect to each weight via the chain rule. Computing the gradient layer by layer and backward from the last layer to avoid redundant computations of intermediate terms of chain rule. Then features of back propagation is a gradient descent method as used in the case of simple perceptron networks with a differentiable unit. It is different from other networks in respect to the process by which the weights are calculated during the learning period of the network. Training is done in the three stages: the feed forward of input training patterns, the calculations and back propagations of the error, updations of the weight, and the work of back propagation is supervised learning, which is neural network uses supervised learning to generate output vectors from input vectors that the network operates on. It compares generate output to the desired outputs and generate an error reports. If the result does not match the generated output vector, then it adjusts with the weights according to the bug report to get your desired outputs. Need to back propagation. Back propagation is error, that is a back propagation of error, and is very useful for training neural networks. It fast, easy to implement, and simple back propagation does not require any parameters to be set. Expect the number of inputs. Then back propagation is a flexible methods because no prior knowledge of the networks. And then neural networks is a supervised learning to generate output vectors from input vectors that the network operates on, and then it adjusts with the weights according to the bug report to get your desired outputs, and then generate output to the desired outputs and generates an error report if the result does not match with the generated output. And then it does not require any parameters to be set for the number, expect the number of inputs, and it's one of the flexible methods. And then advantages of the neural networks are the it is very simple, fast and easy to program, and then only number of inputs are tuned, not only other parameters. It is flexible and efficient. It is too fast than compared with the other network systems, and no need for user to learn any special functions. It is easy to noisy data and irregularities. Noisy data can lead to inaccurate results. Performance is high depends on the input data, spending too much time training, and symmetric basic approaches preferred over a mini batch. And most advantages are its only number of inputs are turned, not any other parameters. It is flexible and efficient, no need for user to learn any special functions, and then it is very simple, fast and easy to program. And one of the main advantages disadvantages are sensitive to noisy data or irregularities and inaccurate results with noisy data. And then performance is high dependent on input data, spending too much training data sets, and the matrix data based approach is preferred over a minimal batch. Thank you.